So picture this. You are standing in a bustling sports bar, right? You look around and there are like 14 TVs all playing different games totally seamlessly.
Yeah, it's a lot of screens.
Right. And have you ever wondered how, one bartender controls all of that without juggling a dozen remotes? Just desperately trying to find the right input for the local game?
I mean, it looks like pure chaos management, but underneath it all, there's actually a highly engineered digital ecosystem doing the heavy lifting.
Which is exactly our mission for this deep dive today. We are unpacking the hidden mechanics of commercial video distribution.
Specifically, looking at our source material on the WolfPack 1080p AV over IP matrix switchers from HDTV Supply.
Yeah, we are going to bypass the basic specs and really look at the mechanisms, like how you abstract a massive hardware array into a simple touch interface.
It is honestly a fascinating look at the evolution of network topography. How data physically moves through a space.
Right, so let's start with that physical layer.
Yeah.
We're talking about pushing 1080p video up to 450 feet over standard networking.
And that is using just a standard CD6 cable and PoE,
Okay.
right? Power over Ethernet.
Exactly, which is huge. It completely eliminates the need for messy power cords behind every single screen.
Yep.
It's like a digital plumbing system where the cables are high-pressure pipes delivering power and HD video at the same time.
Right. But to really grasp it, instead of thinking of standard HDMI setups, we have to rethink the architecture.
Yeah, because traditional HDMI is like a direct train track, a very rigid single destination connection.
That is a great way to frame it. If you want to move a TV on a train track system, you literally have to rip open the walls and lay new track.
Which is a nightmare.
Oh, absolutely. But with AV over IP, you take that dense video signal and chop it up into tiny addressed IP packets. It operates much more like a highly efficient postal system.
And because it is packet switched rather than a direct electrical link, the matrix part of the switcher comes into play.
Right.
You aren't physically hardwiring one cable box to one TV anymore. You are plugging 13 sources and 14 displays into a central network switch.
And letting software act as the traffic cop.
Exactly. It routes those packets wherever they need to go dynamically.
Which fundamentally changes the architecture of a commercial space. You replace those rigid hardware limitations with network flexibility.
So a business can just add a new display or relocate a source without running new, heavy, dedicated cables.
Exactly.
Now, that software abstraction layer is what I find the most compelling here. The sources detail a control system called the WolfPad.
The tablet control, yeah.
Yeah, where a user with an iPad gets real-time video previews of, say, DirecTV or Roku. And they can literally drag and drop those feeds onto a digital floor plan.
To build video walls of any size, the interface completely masks the complex network engineering happening in the background. You just point and click.
But wait, this is where I have to push back a bit.
Yeah.
Routing a 14 by 14 matrix over a standard network. Dragging and dropping live high-definition streams.
You're wondering how the network handles the bandwidth without buckling.
Yeah. I mean, I think about trying to stream a movie at home while someone else is gaming and things stutter. How are they not dropping frames everywhere and just creating a laggy, frustrating experience?
Well, it really comes down to localized bandwidth management and incredibly efficient compression algorithms. The switch isn't hoarding data.
Hey?
It's aggressively pushing packets through with an 80 millisecond switching and latency time.
Wait, 80 milliseconds? That's imperceptible.
Totally imperceptible. The system chops the video, routes it, and reassembles it at the destination display so fast that to the human eye, the transition is instantaneous.
Wow. The sources also mentioned the system comes with SEC security compliance.
Yeah.
And at first I wondered why a sports bar needs SEC compliance.
Well, think about the network itself.
Right. If you are running all your video data over the same IP network that handles your point-of-sale systems, you absolutely need those video packets encrypted.
Precisely. Otherwise, unencrypted streams become a massive network vulnerability. It secures the entire network topography.
That makes total sense.
And what's interesting from an infrastructure standpoint is how this technology scales financially.
Right, because we aren't talking about massive mainframes here.
No, the modular nature of AV over IP means entry setups start around just $150. They scale up to about $4,950 for that full 14 source by 14 display matrix.
And the sources point out that it includes absolutely zero monthly license fees.
Zero, because you own the hardware and the network.
So the core takeaway for you as a listener is that complex multi-screen video distribution isn't about brute force. It is all about smart networking and elegant, centralized control.
It really changes how you experience a commercial environment. You realize those seamless displays aren't a product of endless tangled wires.
Right, they are the result of highly optimized data management.
Right.
So the next time you are in a restaurant watching a massive video wall, you will understand the invisible digital matrix running the show.
Just an invisible digital postal service working in the background delivering packets in milliseconds.
Which leaves an interesting thought to ponder. If a commercial system can instantly route 14 HD video streams over a standard Ethernet network, with zero latency and no monthly fees,
Yeah.
how long until our own smart homes completely ditch traditional HDMI cables and we're just dragging and dropping video streams from room to room over our local Wi-Fi?